Dear students, in the previous video lecture, we were discussing about four-stroke engines. Four-stroke engines. So here, what is four-stroke engine? So in four-stroke engine, the piston performs four strokes to complete one working cycle. Four strokes to complete one working cycle. We know already what is stroke. That is the movement of the piston either from top dead center to bottom dead center or from bottom dead center to top dead center. So that is called the stroke. So like this, in four stroke engine, there will be a movement of the piston four times. Okay, so that is called the four stroke. To complete the working cycle, we need four strokes in case of four stroke internal combustion engine. So what is the complete one working cycle? Here the complete one working cycle means we have to suck the air and fuel mixture inside the engine cylinder. So that is the one work that is done by the moving the piston from top dead center to bottom dead center. Again, the air and fuel mixture will be compressed. Okay, so that is the another stroke, and uh, the air and fuel mixture will be burnt by uh, producing a spark in the spark plug in case of petrol engine, and power will be generated. That is the another stroke. And again, the after burning the air and fuel mixture, there is a exhaust gases or the waste gases produced. Those gases we have to expel outside or we have to exhaust outside. That is done in the another stroke. So like this, four different strokes are required in case of four stroke petrol engine or diesel engine, whatever. So that's why it is called four stroke engine. So here we can have four different strokes, and there is a name for the each and every stroke in the four stroke petrol engine or diesel engine. So first stroke is called suction stroke, and second stroke is called compression stroke, third one is called working or power stroke, and fourth one is called exhaust stroke. Here each stroke takes place in half a rotation of the crankshaft. You know already where is the crankshaft in the engine. The crankshaft is a very important part in the internal combustion engine. So here we can observe in this diagram. So here this is the crank or the crankshaft. Okay, we can observe. So this part whatever you are seeing. So this part is called as the crankshaft. So this crankshaft will convert the reciprocating motion of the piston, the reciprocating motion of the piston is converted into a rotary motion by using a connecting rod. Then that rotary motion is transferred to the crankshaft. So this crankshaft rotates at high speed, and the high speed, okay, rotational motion will be transmitted to the clutch and then to the gearbox in the vehicle. So finally, so the rotational motion in the rear wheels of the vehicle, we will get it from the engine. So like this, the crankshaft, okay, rotates in the four stroke petrol engine or two stroke petrol engine, whatever the engine, the crankshaft is a very important part. So here in this we can see the crankshaft. So each stroke takes place in half a rotation. For every half rotation of the crankshaft, there is a one stroke in the four stroke petrol engine. So like this, one rotation of the crankshaft, okay, there will be two strokes. Okay, two strokes are completed. So like this, another one rotation, another two strokes are completed. Like this, for every two revolutions of the crankshaft, there is a one complete cycle. All these four strokes are completed in two revolutions of the crankshaft. So like this, okay, in these two strokes we can observe these two strokes there is no power. So here in stroke number 3, that is working or power stroke, the power is produced and exhaust gases are expelled again in the another stroke, that is called the exhaust stroke. So like this, in one revolution of the crankshaft there is a power generated in the four stroke petrol engine or diesel engine. In another two strokes or another revolution of the crankshaft, there is no power generated. So next we'll move to the next slide here. So four stroke engines are classified. We know that already. Four stroke engine, it may be a petrol engine or diesel engine. It's based on what is the fuel used. Okay, so four stroke petrol engine or four stroke diesel engine. Okay, so we'll understand one by one what is the working principle of four stroke petrol engine, what is the working principle of four stroke diesel engine. So first we'll understand what is the working principle of four-stroke petrol engine. So it is also called as SI engine. We know that already. SI engine and CI engine. SI engine means spark ignition engine. That is the petrol engine is also called as SI engine, because in the petrol engine we are going to use a spark plug to produce the spark to burn the petrol. In CI engine, that is called diesel engine, is also called as CI engine. In CI engine or diesel engine, there is no spark plug used. Okay, instead of that, you are going to compress the air to very high pressure and temperature. So that high pressure and temperature is sufficient to burn the diesel. Okay, so when the diesel is sprayed into the high temperature air, so it will burn and it will produce the power. So this is called the SI engine. So petrol engine works on the principle of Otto cycle. We know this also. So why it is called Otto cycle? Because the person who invented the petrol engine, his name is called Otto. So that's why the thermodynamic cycle, okay, so in which the petrol engine works, that is called Otto cycle. It's also known as constant volume cycle. It consists of cylinder. We know that there is a very important part, that is the heart of the engine, that is the cylinder that is required, and piston and connecting rod, okay, crank, crankshaft, inlet valve, exhaust valve, and spark plug. These are all the main parts of the four-stroke petrol engine. The spark plug fitted at the top of the cylinder initiates the ignition of the petrol. Ignition means burning of the fuel, that is the petrol. Hence the name spark ignition engine. Okay, so why it is called SI engine, or shortly, or spark ignition engine, because of this. So now we'll understand one by one. So what are all these four different strokes? Why these strokes are required in four-stroke petrol engine? So for each and every stroke there is a one diagram. So like this for four strokes. Okay, first stroke, that we call it as a suction stroke. Second stroke is compression stroke, and third stroke is working stroke, or the power stroke, and fourth one is called exhaust stroke. So now first we'll come to the suction stroke. What is suction stroke? So before that, in this diagram we can observe, okay, there is a piston. This is the piston, and this is called the inlet valve, and this is called the exhaust valve. We know that already. What is the function of inlet valve? So inlet valve will allow the, okay, we are discussing about petrol engine here. Okay, we can observe this is the spark plug required in the engine, and this is the inlet valve, and this is called the exhaust valve. This inlet valve, the main function of the inlet valve is to allow the air and fuel mixture into the engine cylinder. So this is the cylinder. Inside the cylinder, the piston can freely move up and down. Okay, this is the connecting rod. The movement of the piston, the reciprocating movement of the piston, will be converted into rotary, okay, motion in the connecting rod, and it will be transmitted to finally to the crankshaft, so that crankshaft rotates. So here the inlet valve will allow the air and fuel mixture to enter inside the engine cylinder. The exhaust valve, okay, is used only to exhaust the waste gases or exhaust gases produced at the end of the, okay, at the end of the stroke, that is the exhaust stroke, or okay, the after completely burning the air and fuel mixture inside the engine cylinder. So in the first stroke, that is called suction stroke. During suction stroke, the inlet valve opens, air and fuel mixture will enter inside the engine cylinder. We can see the exhaust valve is in the closed condition, only the inlet valve opens. The piston moves from top dead center to bottom dead center. When it moves top dead center to bottom dead center, okay, so what happens, the partial vacuum will be created inside the engine cylinder. So that is the pressure inside the engine cylinder is less than the atmospheric pressure. So due to that, the air and fuel mixture will be sucked inside the engine cylinder during the suction stroke. So the piston moves down, okay, to the bottom dead center, or it's also called as BDC. So this is the first stroke. Okay, so in this stroke the air and fuel mixture will be sucked inside the engine cylinder. So now when the piston moves, in the second diagram, come to the second diagram here. So this is called the compression stroke. So in this stroke the piston is completely at the bottom dead center, or BDC. Here is just it is moving down. So here now the piston is at bottom dead center. So this inlet valve also closes. Okay, so inlet valve is also closed in this diagram, we can observe, and exhaust valve is also closed. So both are closed entirely. The cylinder volume is filled with air and fuel mixture. The piston again starts moving up. It will move from bottom dead center to top dead center. So when it moves from bottom dead center to top dead center, what happens, the air and fuel mixture will be compressed. So that we can observe in the third diagram, that is the working stroke. In this stroke the piston is at top dead center and the air and fuel mixture is completely compressed. Okay, so when the piston moves or reaches the top dead center, so what happens, this spark plug will, okay, produce the spark. When the spark is produced, okay, so air and fuel mixture will capture the fire and it will start burning. So when it starts burning, okay, so when it burns, the high temperature, okay, is involved and high pressure is involved. So due to that, that high pressure and high temperature acts on the surface of the piston, top surface of the piston, so that piston will be pushed in the downward direction at high speed. So that this is called the working stroke or the power stroke. So actual the generation of the power or actual development of the power takes place at the, okay, in the working stroke or the power stroke. So by burning the air and fuel mixture, so that piston moves at high speed in the downward direction. So again the piston moves from top dead center to bottom dead center, so during the power stroke due to the burning of the fuel. So this is the third stroke. So again, now we can see this is the last stroke, or it's also called as exhaust stroke. So during this stroke, what happens, the air and fuel mixture is completely burnt, and okay, the power is developed, so that piston moves during the power stroke. So here in this diagram we can observe the piston is at bottom dead center, bottom dead center, or okay, it is BDC. Okay, so this is, okay, TDC, top dead center. Okay, so now the piston is at bottom dead center. Okay, so now the exhaust stroke begins. Again the piston starts moving up to the top dead center. So what happens when it starts moving up, this waste gases or exhaust gases will move up, and the exhaust valve is opened and inlet valve is closed. Again the exhaust gases will move, okay, outside through the exhaust port by opening the exhaust valve. So this is how the internal combustion engine works, and again the cycle repeats again. Okay, the first stroke, that is the suction stroke, will begin. Air and fuel mixture will be sucked inside the engine cylinder, and the piston moves from top dead center to bottom dead center. Due to the vacuum, it will suck the air and fuel mixture completely inside the engine cylinder, only the inlet valve is open. So again the compression stroke begin. So it, okay, both the valve will be in the closed condition. Again the piston moves up and it will compress the air and fuel mixture to a very small volume, that is called the clearance volume. So at the end of the compression stroke, the piston is at top dead center. The spark plug will produce the spark and it will burn the air and fuel mixture, so that the piston, due to the high temperature and pressure produced by burning the fuel, okay, pushes the piston in the downward direction, though that, so that piston moves down at high speed. Okay, so again the whatever, by burning the fuel, exhaust gases or waste gases are produced. Those gases we have to expel outside, or we have to exhaust it outside to the atmosphere. For that we have to move the piston again in the outward direction. So like this, there are four different strokes. First stroke is called suction stroke, second stroke is called compression stroke, third stroke is called working stroke or the power stroke, and fourth stroke, that is called the exhaust stroke. Okay, so like this, four different processes are completed inside the engine cylinder by moving the piston up and down. Okay, okay, up and down, or four, by using four different strokes by opening and closing the inlet valve and exhaust valve. So here, like this, to complete one stroke we need half a revolution of the crankshaft. Okay, crankshaft will rotate for the suction stroke half revolution, for, okay, compression stroke another half revolution. So like this, one revolution of the crankshaft, okay, is completed in these two strokes. Okay, but here we don't develop any power. So here another two revolutions are completed by developing a power in the power stroke or working stroke and exhausting the gases. So like this, okay, two revolutions of the crankshaft required to complete the whole cycle, that is suction stroke, compression stroke, working stroke and the exhaust stroke. So this is how the four stroke internal combustion engine works, and it will develop the power and it will make the crankshaft rotate at a high speed. Okay, so next class, or next in the next video lecture, we'll understand how the four stroke diesel engine works. Okay, so thank you.